Today we're going to start the beginning of section 13.4, which is we're going to now approximate values of trig functions with our calculator. So we have some concepts we have to understand about how to use the calculator. We're also going to talk about new units of measure for angles. And we'll get partway through this note outline and then pause, and we'll pick it up on Friday again. So there's an assignment accompanied with this, but that assignment it's not tonight's assignment. You'll study for your test tonight, and then you'll pick this assignment up after your test. So to start, you've seen some of these before if you were checking your answers. So the three functions we have right here are the reciprocal functions: cosecant, secant, and cotangent. Excuse me. And we first introduced the reciprocal functions in this form because we know that the sine of cosecant is equal to y over r. So the cosecant of an angle is equal to r over y. Okay, so that's what we're looking at here in red, but if we look at it, I can also express the cosecant function as a reciprocal in terms of sine as opposed to a reciprocal in terms of r and y, which is the value of the cosecant function. So if you need to calculate the cosecant of an angle on your calculator does not have the reciprocal functions embedded in it. So what we have to do is we'd have to divide 1 by the sine of the angle you're working with to calculate the cosecant of an angle. Same with secant, right? If I wanted to calculate secant of an angle, I'm going to calculate 1 divided by cosine of that same angle. That goes the same for cotangent, right? I'm going to divide 1 by tangent of that angle, okay? So an example down here is if we had to calculate the cosecant of 30 degrees, we can't just add that into our calculator. So what we're going to do is we're going to calculate 1 divided by the sine of 30 degrees in the calculator, and that'll give us a value of 2. And that makes sense because the sine of 30 degrees is 1/2. And if you remember, sine is equal to your y over your r, right? So your y in this case is actually 1/2 over 1. The r is 1. But if we take the reciprocal of that, simplified fraction, we end up with 2, which is what we're looking at right here, right? So this is just kind of verifying that. An alternative way to do this on your calculator without expressing cosecant, secant, and cotangent as 1 divided by their reciprocal function, there is a key in your calculator. Now it depends on your calculator model. Many calculators have a key on it which reads x to the negative first. Alternatively, some calculators, instead of having x to the negative first, they have it expressed as 1 over x, which is the reciprocal of x. Either of those keys mean the same thing, and they're the reciprocal key, right? So whatever value is on the screen in your calculator, if you were to hit that key, that reciprocal key, it's going to take the reciprocal of your value. So alternatively, you could calculate the cosecant of an angle by just simply taking the sine of the angle. Now remember, close that group after you type in the angle. And then I usually put the sine function in groups as well. It really depends on the syntax of your calculator. But I'll do sine of the angle, and then whatever that value is, I'm raising it to the negative first. And that's the negative first key on the calculator. That's your reciprocal, which basically will do this for you. So you don't have to go in and type 1 divided by. So I'm not particular on which method you use, if you use any of these or if you use any of these. Do what's comfortable and what you can get through quicker. But I just wanted to give you an alternative way to look at it from that perspective. So calculating basic angles with the 3 main trig functions, cosine, sine, and tangent for 21 degrees. You're just going to type in cosine 21. You do not need to enter the degree unit into your calculator. And your calculator should spit out 0.933 and then a bunch of decimals after that. We're gonna round these all to 4 decimal places. So whatever that 5th value is, if it's 5 and above, you're gonna round up. If it's not, you're gonna just keep it the same. So sine of 21, 0.3584, and tangent of 21, 0.3839. It is important that you go to at least 4 decimal places when you're approximating these, and then we're gonna do, oops, I thought I had, the reciprocals, right? So you can do this 2 ways, but the secant of 21, the only way to calculate it in your calculator is to do 1 divided by the cosine of 21 degrees, or you could do the cosine of 21 and then hit the reciprocal key on your calculator, that x to the -1 or 1 over x key. Both of these statements are identical, and they should both produce 1.0711. And that holds true for the cosine of 21, cosecant, excuse me, and cotangent of 21, right? Just taking the reciprocal of the sine of 21 degrees, or expressing it as sine 21, and then hit the reciprocal key, but you should get 2.7904. Same with the tangent function, you should get 2.6051. If your calculator is not producing these values, one of 2 things could be occurring. One, you could just be entering the syntax incorrectly as you type it into your calculator, and you can meet with me and we can talk about it. That is less likely to be occurring, but it's a possibility. The other thing is your calculator has 3 modes set for angles when it works with the trig functions. So that would be degrees, and then radians, and then gradients. We're gonna work mostly with degrees and radians. So if the calculator mode is set to radian angle, it's going to work as a radian as opposed to a degree, which are different units of measure. So we want to convert that to degrees, shift the mode in your calculator to degrees. You can look it up, you just type the model number in your calculator and just include, radians to degrees or degrees to radians, and there should be a significant number of hits that will walk you through or provide a video on how to do it, or just bring it to me and I'll show you. So that kind of deals with how to use your calculator to approximate these angles, and then we're going to move into the new angle units.